Okay, trying something a little bit different today. See if I can use this iPad as a document camera. So we're talking today about volume of rectangular prisms and cylinders. So we're going to start with just kind of a review here. Perimeter and circumference are one-dimensional. So we're going to put one-dimensional in there. And if you look down here at this circle, if I'm just going to trace around the circle and get the distance around, which would be pi times the diameter, that is one-dimensional. It's like a line going all the way around. Same thing with this rectangle up here. I just do the flat rectangle and nothing else, not the box. That's perimeter. Okay, so that is one-dimensional. Then the area of a rectangle and a circle, area equals length times width. So when you go to area, you're doing length and width. So now you go into two dimensions. So not only are we in a line and being linear, but we're actually going into another dimension and we're doing a flat surface. So it's surface area. So surface area or area is two-dimensional. Okay. Then to find the volume of any prism or cylindrical object, which is three-dimensional. It's coming off the paper at us now. What do we do? Okay, well, I'm going to try to show you a little demonstration. I'm going to start with the rectangular prism. Okay, and I'm going to look at the rectangular prism. Let me think about this here. Okay, and I'm going to pretend like this rectangular prism is tilted up and this is the base right here, just for my demonstration purposes. Okay, so before we actually look at the area, I'm sorry, the volume, let's look at the area. Okay, this is just the base. Okay, and we're using this as the base, so it's sitting flat on the table, and this one's a little bit bigger. Okay, but when you look at that, it's 2 rows and 3 columns. So how many squares do we see there? We see 6. All right, and 2 times 3 is 6. So if I was just looking at the flat squares on the bottom or the base, which we're tipping this up, kind of like a, I don't know, a block that's on its base anyway. The base would be 6 squares. Now, if I want to bring it off the page like an artist, and I want to give it this height, well, it's 6 feet tall when I set it up. So I would take this and I would say, okay, there's 6. Now we have 6 cubes that are 1 foot by 1 foot by 1 foot, and we're going to stick those on top. So now there's 2 tall, and now it's 3 tall, now it's 4 tall, now it's 5 tall, and now it's 6 tall. And you're like, well, wait a minute, Miss Stevens, I can't see that. Okay, so let me try to pick it up and let you see I've given it height. Okay, so now it's tall. Oh, there we go. Okay. All right, so it's come off the page. Okay, it's got dimensions. It's tall now too. 6 feet tall, 3 feet wide, and 2 feet deep. 2 feet deep this way. Okay, if I lay it down and look at it like it is on the page, then it's come off the page 2 feet. There's its height. I'm looking at it that way. So now it's giving it a third dimension. Okay, so that's why we say length times width times height. So we're in 3 dimensions. So if I want to find the volume of this rectangular prism, I can go back up here and I can say I'm going to take the area of this base, which we made the base 6, and then we give it height by multiplying it by the height, which is 6. So I'll put 6 of these on here. Okay, so a shortcut is just to say, and that you think, well, Miss Stevens, this doesn't look like much of a shortcut because I could just do length times width times height. But it will be when we get into different figures. So the area of the base times the height. And you might say, well, Miss Stevens, what if I don't want that? I don't want this to be the base. Well, if 6 by 3 foot is the base, then here's the base. And now when I give it a second tier or a second story, missing one under there. When I give it a second story, Now I've got it height this way. So it doesn't matter which base I use, but once I multiply that base times the height that it has, it will bring it off the page into a three-dimensional, where are we at? Three-dimensional object. And I just had that off the page when I showed you. Crap, there it is. Okay, so area of the base times height. So let's go ahead and do this one. Okay, so the shape, it's a rectangular prism. The shape of the base is a rectangle. Okay, the area of the base. Let's go ahead and use the base as what it looks like on this picture. 6 feet wide and 3 feet long. So the area of the base is 3 feet, let me see, times 6 feet. Okay, and then I'm going to take the area of the base times the height, and that's written down here. Okay, the height is 2 feet. So this is area. So that's going to be 18 feet squared. So that's how many feet I have on the flat surface. I can look at the top of it and see 18 of them too, but that's flat, and that's two-dimensional. So when I go to the volume, then I'm going to do the area of the base, which is 18 feet squared, times the height, and my height is 2 feet. 2 feet up, coming off the page. So now 18 times 2, that's 36 feet to the third power, because I have feet squared times another foot makes feet to the third power, which is the same thing as 36 cubic feet. Okay, and then that will be your final answer. Now there's a place down here at the bottom for you to write that. If you want to just box it in up there, that's fine. Okay, so now let's look at the cylinder. Okay, cylinder works the same way. So we've got cylinder, C-Y-L-I-N-D-E-R. Shape of the base is a circle. And we're always going to say the base is whichever figure it is that that names it. Okay, so a cylinder, circle. We could have a triangular prism. In that case, there'd be a triangle at the base, so you would always use that as your base, whatever the defining figure is. We'll do more of that later. But when we look at a figure, okay, and we look at just the area of the base. Okay, so I'm going to pretend that this is the base right here, okay, this little round thing, and we're just looking at the flat surface. Okay, so the area of the base, we know, is going to be pi times the radius squared. All right, so when we look at that, we're then going to take that times the height. All right, so area of the base, pi r squared, times the height. And in this situation, I should have gone ahead and put the radius in there, sorry. So the radius is going to be 4 centimeters, and I'm going to square that. And then I'm going to multiply that times the height, which is just 6 centimeters. All right, so when I square the radius, I get 16 centimeters squared, because I'm squaring both. And then I'm going to multiply that times pi. And then once I get that answer, I'll multiply it times 6 centimeters. All right, so get your calculators out. Turn them on. I'll get the glare off of there if I can. There we go. Okay, so I'm going to take pi. I've already squared that, and if it's a big number or a number you can't square, you would square that first, and then you would multiply it times pi. But I'll do that. I'll take 16 times pi, and I've already got it in pi mode, so it's going to come out to be 50.265482446. Now, I say leave it on the calculator and don't round it, but show me on your paper what you've got. Okay, and we're going to multiply that times 6 centimeters, because if I go ahead and round it now, it's not going to be as exact as if I wait, leave this in the calculator, then multiply it times the 6. And when I do that, now I have 301.5. Now here's where I can round. It's 592, so the 2 means I'm going to leave that a 9. And now I'm taking, this was centimeters squared times centimeters, so that's centimeters cubed. So, or 301.59 cubic centimeters, okay? And here's a cube, all right? That's how many would fit inside of that cylinder. Of course, not this measure, but you get the idea. Okay, so your homework is, you'll do it in class tomorrow, but this is what I'm going to be looking at. I also have your homework from last night, or from today in class, and what I'll do is just lay it under here kind of slowly, and you can pause it. Okay, so there's 1, 2, and 3 for the rectangular prisms. I did make a net for this one. On the rest of them, I just tried to label them and use the labels there. This last one, number 3, is pretty hairy because you have all these different faces on this L. Okay, so I tried to name them all, and even the ones that aren't visible, I put arrows to show you that they're not shown, and I wrote out their descriptions, and I have it labeled on here, and then I had to add all those together. So anyway, I got 2,610 meters squared. I could have made a silly mistake because I did this very quickly at lunch. Yes, I gave up my lunch. No, I ate while I did this. Okay, here's the other side. Somewhere. Here it is. Okay, so we got, there's number 1 on the back, surface area of cylinders, and 2. And I went ahead and wrote out all the nets on those. And then here's number 3. And like I said, you can pause it so you can see those better. Have a good evening.